In this problem, we want to find the focus and directrix of the parabola of the given equation and then graph it. We've got y squared equals 8x. Now, first thing we have to do is determine which formula to use. Notice the square root is on the y here. So this top one, the square root is on the x. The bottom one, the square root is on the y. So we want to use the bottom one. And we're going to try to rewrite it as y, and we're going to try to get it to match this form here. Y minus k squared is equal to 4p times x minus h. Well, we have just y squared over here. We can rewrite that as y minus 0 squared. Because y minus 0 is y to the second power gives you y squared. Now over on this side, we need a parentheses before the x. And you can always create this parentheses before the x by factoring out whatever number's in front of the x. So I'll factor out an 8. Okay. Now we want to rewrite the 8 as 4 times something. And this one's pretty easy. 4 times 2 gives you 8. And then this x, we want to rewrite it as x minus a number or x plus a number. And we'll rewrite it as x minus 0 or x plus 0. And now it's in the right form. We got y plus or y minus a number squared equals 4 times a number, 4 times p, times x minus or x plus a number. Well, whatever number is inside with our y is our k, and it's going to be opposite sign, though 0 doesn't have a sign. So k is 0. Whatever number is right here in front in this parentheses is our p, so telling us p is 2. And whatever numbers with our x is our h, and it's going to be opposite sign, though 0 doesn't have a sign. So h is 0. Now I'm going to go ahead and find a vertex. We need it for the graphing. They're not actually asking for it. Our vertex is always hk, no matter which formula. So that'd be 0, 0. Okay, now we're working with the bottom form. So if I come here, the bottom form, my focus is h plus p comma k. So h plus p comma k, and that's our focus. Well, h is 0, p is 2, so we got 0 plus 2 comma k, which is 0. So our focus will be 2, 0. That's the first thing they're asking for. And our directrix. Again, we're working with the bottom formula. The directrix is x equals h minus p. Well, h we said was 0 minus p, which is 2. So we get x is equal to negative 2. Now for graphing purposes, our vertex is 0, 0. So put a point there. Our focus is 2, 0. So put a point there. Our directrix is x equals negative 2. So here at negative 2, we'll put a vertical line. That's our directrix. Now notice how your vertex is 2 units away from your directrix and your vertex is 2 units away from your focus. The vertex should always be exactly in the middle of those. So that's kind of a check. Okay, now we'll drop a point. Now look at where my point is right here. We want the distance from that point to the directrix to be the same as the distance from that point to the focus. So we keep moving our point until they are the same. Doesn't matter where you put your point at, you just got to make sure those distances are the same. That's as good as I'm going to get. So just to reiterate that, this distance here from that point to the focus should be the same as the distance straight over to the directrix, forming a 90-degree angle. Okay, I drop another point here. And if I drop it here, I see that I need to increase the distance from my point to the directrix. I'm not very good at these. That's as good as I'm going to get eyeballing it. But again, this distance from my point to the focus should be the same as the distance from the point to my directrix, forming a 90-degree angle. Now once you have 2 points, then you're ready to draw your graph, because you remember parabola is curved. So that's going to be curved like that. And then by symmetry, it's going to look the same down here, it's just reflected. And those would be our answers.